Ladies and gentlemen, thank you for turning out on a cold night. So not very often you get a sort of crowd on a geology meeting, usually much smaller. I think there may be something a little more controversial this evening than our normal affair. We normally meet on the second and fourth Wednesdays a month, in case any of you are interested in returning for another geology meeting. A fairly full programme for the next 6 months. Right, our speaker tonight is Graeme Phipps. Graeme graduated with degrees in BSc Honours in Geology and Honours in Geophysics from the University of Alberta, Canada. He spent 50 years in the oil and gas industry as a practicing geologist and geophysicist, and as a manager, executive and now director of various international oil and gas companies. Graeme has spent his entire professional career looking into the impact of climate change on sea level changes and the resulting sedimentary deposits throughout the recorded geological time, a key element of oil and gas exploration. His particular interest in relationships between carbon dioxide, temperature and climate change prompted him to research the subject in much greater detail. He's received no funding for his work, doing it purely to pursue the science in a more detailed and rigorous scientific way. This presentation is based on his extensive research into the subject. I'll give you Graeme Phipps.
Thank you, Colin. Well, that was excellent. And in conclusion, I'll got a little bit to say. Thank you very much. So I think you know why we're here. I'm giving this talk on CO2, climate, and temperature and the relationships. Colin's already given you a bit of my background. Geology is kind of like history, except we look at rocks and fossils and not just books. We go back further in time, but very similar. And the geophysics is the physics side. So you'll see the elements of my keen interest in science and physics has influenced this presentation. What you're going to see is a little bit contrary to what you hear in everyday media. And I ask you to take a look at the quote there from Tolstoy. But really, I just ask you to have an open mind, hear it out. At the end, I'll be open for questions, discussions. And if you're still quite concerned, we have a bar open afterwards, so I can bribe you with that too. No, there'll be a chance to visit and discuss after we have the presentation as well. So my conclusions and my findings are a little bit contrary to what you see. First of all, I'm going to show you that warmer temperatures are good. Well, that shouldn't surprise us. Where do we go on holidays? In warmer climates. More CO2 is good. That shouldn't surprise us either. If you ever go to any of the greenhouses, the people running those often will put more CO2 into the atmosphere to help the plants grow faster. Global warming is not caused by increased CO2. I think anybody who's familiar with ice ages, and I'll show you evidence of that, will know that climate has been changing well before mankind came along, and I'll show you a lot of evidence to support there isn't a good correlation. Even though over a limited time period you may be influenced by that. If you look over the big picture, which we do in geology, you'll see that. We're not in a climate crisis. Media loves, anytime there's a storm or disaster, they love to jump on it. But as we do as geologists, we look back over a longer time period. And when you do that and you look at the statistics, you'll see that, no, there isn't a change. It's consistent with what's happened in the past. And the science is not settled. You've heard, I think one of our politicians said the science is settled. Well, by the nature of science, including what I show you, it's not settled. Science is always open to new ideas, new concepts, etc. Okay, let me get into this. I'm going to start with look at climate and temperatures over time. This slide shows you the change in temperature over the last 600 million years. And you'll notice we're in actually a bit of a low over the history of the Earth. And it's been much higher over the last time period. You can say, well, that's interesting, but we need to focus on mankind's existence. We're not worried about dinosaurs and what they did then. Well, if you look at the time period of mankind, you'll see that the history of man has done better in the warmer periods. For example, the Warm Bronze Age, the Minoans prospered. It was followed by the Greek Dark Age when it was much tougher for them. The same repeated itself, the Roman Warm period. And you'll recall, I think you know, that the Scots in Scotland, they were growing grapes. The Romans were growing grapes up in Scotland where it was warmer. And that was followed by the devastating Dark Age. The medieval warm period, we saw gain, civilization advance, and that was followed by the Little Ice Age. And it was very tough. You know, that's when we had the Black Plague in London and other kinds of tough environments for people. So the message here is the warm periods, not just now, but over history, when temperatures were anywhere from 1/2 to 2 degrees centigrade on average, higher than today, we shouldn't panic and be afraid, oh, it's going to go another degree. We've been there, done that, and did very well. In fact, when you think about warm and cold, people die much more from cold temperatures than warm temperatures. And coming from Canada, I know that, where it gets quite cold. Let's look a little bit now at CO2 levels. Same thing. CO2 levels have changed dramatically over time when you look over the whole geologic record. And they're not, the shoot up that were shown on the graphs to scare us is minimal compared to what's happened over time. For example, in the Jurassic, when dinosaurs were running around, it was 7 times higher CO2. And concentrations of CO2 in this room right now, if we had a gauge, is probably around 1,000 parts per million. And that's just because we're all breathing CO2. And there's tests, for example, the US Navy submariners, they were breathing 3,000 to 5,000 parts per million for 3 months at a time, and they've studied, and there's no negative impact. So we're at 420. You know, there's lots of room and there's no negative impact, and the tests are already done and the people are experiencing that. Let's look a little closer at that recent decline over the last 140 million years ago. What I wanted to point out, that it was dropping to 180 parts per million. If it had gone another 30 parts per million lower, plants couldn't grow anymore. So if we should be worrying, it's not that it's going up, that we're fortunate when it was going down, it didn't reach that level where plants couldn't exist. That's that red line of death. CO2 also has a big impact on plants' growth. Here's a picture taken from NASA, and it shows the change in greening of the Earth from since 1980. The Earth, they took satellite images in 1980 and then at present time, and a 40% greening. And that's mostly in the deserts, or the desert edges. And that's because plants don't need as much water when there's higher CO2. They don't open up their pores as much, and they can retain the water. Here's an example of an experiment that shows the impact of just changing the CO2 level on growth. So everything else was the same, and they went from 385 parts per million up to 835 parts per million for the trees. Look at the difference in growth. And it's typical in greenhouse growers to put it from 8 to 1,200 parts per million, the optimum, which is kind of the optimum for plants. We see that not only for the plants in the experiment, but in general. The world is able to provide, and the farmers are able to provide, much better crop yield because of added CO2 and the bit of warming. That doesn't hurt either, you know, as far as the life, extended growing seasons, etc. But you can see significant improvements with CO2 increasing. Now let's look a little bit at the relationship between CO2 and temperature and climate change. Because we're being told that CO2 is causing climate change. But when you look back over time, you don't see that relationship. And in particular, I'd like to point to about 150 million years ago. Oops, sorry. I don't know about this pointer. But right around in here, you'll notice that CO2 was at a peak and temperature had gone down, the exact opposite. Then temperatures stayed flat for about 100 million years or so, and CO2 continued to decline. So over historic time, there's no relationship or correlation between CO2 and temperature. Well, let's look a little closer and see what's happening. In the glaciers, they do cores, and they dig deep cores into it, and they can look back over time, and they can get through the trapped air bubbles, etc. Very accurate information about the amount of CO2 and the temperature. And what we see is a pretty good correlation between CO2 and temperature, but the exact opposite of what you're being told. Temperature changes first, and then CO2 changes. So it can't cause it if it occurs after the fact. In fact, you can do an experiment yourself. I encourage you to take a bottle of bubbly water or a pop or something, pour half of the into a glass, put it in a warm room, put the other half in the fridge, come back and have a sip an hour later, and you'll see that the warm temperature, the glass in the warm temperature is much more fizzy. In other words, the CO2 is escaping, where in the cold temperature it's not. So this is, sort of something you can try yourself. So there's no correlation between recent temperature and increases in CO2. There is, surprise, surprise, a good correlation between solar activity and temperature. In other words, the sun is what's driving these things. Surprise, surprise, we see that every day. But when you look at the data, you can see that, and you don't see the correlation with CO2. Now let's look at sea level, because that's something that certainly could impact us here in Jersey. Well, surprise, surprise, sea level has been changing as well throughout geologic time. In fact, that's how I make my career, is chasing sea level. Because when it changes, the reefs go out, the beaches change, etc. So that's very important in our business. So those are just some graphs showing the changes from two different sources. We see the same information here in Jersey. Here's some examples. For example, 6,000-year-old dolmen at St. Martin's. At that time, Jersey was connected to France. There was, and after that, sea level rose and Jersey became an island. These same dolmens you see in Jersey, the same ones, you go across the water into France and start looking around, and I found them. There's dolmens that look exactly the same as that. At that time, they were all just walking back and forth. And the other good evidence is if you go to St. Juan's, you can see some petrified wood right on the beach. Well, that meant that in the past, there was a time when trees were growing there. The coast was further out. When sea level was lower, we had some forests and some swamps there. And then as sea level rose, the beach moved inland. So the evidence is right in front of us. And of course, if you go walking through the island with a geologist, they can point out, because our rocks are telling us this all the time, the changing impact of climate with the deposition. I'd like to go a little bit more what's behind sea level changing and ice and water. Here's a simple experiment you can do. If you fill a glass with ice and then pour some water in it, and watch what level the water's in the glass with ice, and then you come back and let it melt and go back and look again, is at the same level. What this means is, and it's my little science coming in, the Archimedes principle, is that the volume and the mass of the ice cube in the water is the same as when it melts. So there's no change. You can test it yourself, and that's the concept. So keep that in mind. So the only way that sea level can rise is when ice goes off land and into the ocean. Ice on the ocean, when it melts, makes no impact. So it's just something to keep in mind. Well, where did the ice come from? There was a time when the glacier covered not only North America, but Northern Europe and Northern Asia. All around was covered with the last ice age. So you can imagine when all that ice left the land and went into the ocean, it would have a big impact on sea level. And today, most of it's gone. There's still ice in Greenland and in the north, but much less. And so you'll see the impact on sea level rise has flattened out much more than it was in the past. So here's a schematic that just shows that effect. When we had a lot of ice on the northern continents and it was melting, we'd have a rapid rise of sea level because there's a lot of ice, a lot running off, and it would drive up sea level. And then later on, when you have less and less, sure enough, we're in that lower rise sea level rate. So here's some actual graphs that say the same thing, except measurements. So sea level rise from 1700 to 1988, you can see the last from about 1844 on, fairly constant sea level rise, but it didn't change when CO2 went up. It's flat. It's the same rate that we've had before. So CO2 is not impacting this, in spite of what you're being told. And the same thing if you measure the ice on the glaciers in the Arctic and the Antarctic, what's happening, you don't see a change in the rate of melting recently with CO2. It's not supported by the data. Here's a look at Greenland. We hear stories about, oh, Greenland is melting 6 times faster than it was 30 years ago. Well, 30 years ago was a bit of a lull. If you went back 60 years and tracked it, you'd get a different answer. So you have to be very careful when you read things in the paper and the media. Just put it in perspective, stand back, and as geologists, we like to look over a much longer time period, and we can see some very interesting things. And in fact, in Antarctica, it's actually been expanding, not declining. So the evidence in Antarctica is the ice in Antarctica is actually increasing. There's the report, and it's interesting because a lot of what I'm saying today, some of you are shaking your heads and stuff. Fair enough. You'll come to the end of this. What I'd really like to see happen is a proper debate. I'd like to have a debate in Jersey where I can bring in the scientists that support this, and the people that say, no, that's not true, bring in their perspective, and let's have that debate and discussion, because I'm giving you my biased, I don't think it's biased, but potentially, view on this, and I encourage this. So I'm going to be calling for, and have been calling for, an open debate here in Jersey where both sides of the party can talk and people can listen, and then you can make up your own minds. Today I'm giving you one side, but just because you've heard in the past the other side of the story. So I think that's only appropriate for today. So let's dig into CO2. What's the big deal about CO2? Well, greenhouse gas, which is the thing that keeps the heat in, it's only 0.8% of the total atmosphere. And CO2 is 5% of the greenhouse gas. So that means that CO2 is 0.04% of the total atmosphere. So what we're talking about is playing around with that 0.04%. Well, to put that into context, 4 bathtubs of water would compare to the CO2 at 0.04, and look at that compared to the entire water in an Olympic swimming pool. Just to put it into perspective. But that 5% of CO2 and in fact most of the greenhouse gas, which in fact is water vapor, thank goodness it's there, because that's what keeps this earth warm. Here's a picture of the effect of the greenhouse gas and what we see happening. So you see the sun's energy coming down, hitting the earth, bouncing back up. Some of it hits the greenhouse gas effect and bounces back, and that's what gives us that extra heating effect that allows us to live and be warm, and the rest of it's gone. But when you look into the actual science of the CO2 molecule and what happens, it changes, is logarithmic, not linear. In other words, it's just like a sponge. When you first use a sponge and water, it picks up a lot of water. But when it gets full of water, it doesn't work so well, does it? Well, that's what's happening right now. We're at that stage, we're at the tail end of the effectiveness of CO2 on keeping the earth warm. And if you look back over time, I showed you data that CO2 is 7 times higher and the temperature wasn't runaway. So the experiment's already been done, has been proven, but now I'll go into a little bit more of the science because my bias as a scientist. Here's a very interesting data that talks to the theory behind this, about the CO2 molecule and its heating. So Max Planck delineated the spectrum of radiation from warm bodies. And the impact, he showed that the impact of doubling CO2 from 400 to 800 parts per million is 0.71 degrees centigrade. And because of the nature it's exponential, doubling it from 800 to 1600 adds only 0.35. And if you double it again, you only add 0.17 because of the nature of this. And this is proven scientifically, and it's been demonstrated in the past when we see the relationship between CO2 and temperatures, and here it is in theory. Sorry, one last point. Clouds, for example, we talk about the CO2, and remember I said it's only 5%. Well, clouds, if the cloud cover more than half of the planet. An increase in low cloud cover of only 1% could have the same effect as doubling CO2. So remember I went from 4 to 800 to get 0.7? All you need to do is change the cloud cover just a little bit and you're having the same effect. So it's important we put these things into perspective when we look at these. you can read through this. It's just the scientists that have done the work. And there's a lot, I got a lot more, but there's in my studies. But here's some of the key scientists. William Happer and I won't try and pronounce William Van Wagengarten were the ones who I showed you on that curve before. But there's other scientists too that have done it. In fact, not only have they done it theoretically, they've actually tested it. They've got their test tubes. Of course, here's in a test tube is experiment, and they've doubled the CO2, and they tested the absorption, and they can prove. In fact, what they're coming up with is even less of an effect than what I talked to you about. So this is not only in theory, but it's been tested, and the effect of CO2 is shown to be here. And climate alarmists have never been able to explain why the Earth in the past, because they agree with the data, that I showed you about CO2 and temperature, they can't explain why the Earth has never experienced the projected runaway temperatures when CO2 was over 10 times what we have today. And I mentioned to you that the test has been done, and nobody can explain that, although, I'll show you a little bit of what they're telling you. So here's a little bit more look. We talk about a crisis. We're runaway temperatures. When you actually look at the data, when you stand back and look at the actual data, you see certainly from 2014 to 2023, it was pretty flat. Remember, CO2 has been going up, and I completely agree with that, and that's because of the emissions of CO2 from mankind and natural emissions. You've got a volcano, and that makes a huge amount of CO2. But nevertheless, over that time period, it's flat. If from 1978 to 2023, you see an increase. Of course, when you stand back and look over a broader perspective, and which I'll show you, it's pretty minimal, but nevertheless, it's increasing, but not much. And there's the NOAA data that says since 2015, the same part, no warming, even though we've had massive amounts of CO2 added in the atmosphere. What about the other crises we're hearing about? Well, let's look at them one by one. U.S. heat waves, when you look back over time, the measured U.S. heat wave index, the worst time was the 1930s, the dirty 30s. You've read about that, the depressions and how that was. Other than that, it's pretty flat. Let's look at some of the other disasters. Well, what about floods? What about very dry periods? Yes, they happen, but when you look at it over time, you don't see a change. In other words, it's natural. What we're seeing, when you actually look at the data, and each one of these, you can check the research, and the reference is there. So we certainly don't see it in droughts and flooding. They happen, but they've happened in the past, and they're going to continue to happen in the future. That's the nature of the world. Well, let's look at hurricanes, tornadoes. Oops, same effect. It's not changed. In fact, tornadoes, you could argue, is going down, but I'm sure it'll bounce back up and we'll have these effects over time. Forest fires. Well, we do get some big forest fires. We know about the one in California. But when you actually track, this is data from the US, the number of forest fires has actually been going down, not up. In fact, the impact of this one in California, the reason it was so bad was because they weren't doing proper forest management. There's a lot they could have done to prevent that, including filling their water tanks, but that's another story. pH, we hear about the oceans being acidified and all the fish are going to die and well, through the history of the Earth, you've seen the evolution of life starting in the marine. CO2 levels were much higher, much more higher than today, and there was no acidification of the ocean. What happens is we get deposits of limestone and reefs and all this sort of stuff on the ocean. So it's it has its own natural curing effect. Well, what about the models? The computer models tell us that it's going to go. They must be right. Well, when you actually look at the model results and compare them to actual data, because they've been out for a while, what you see is that the data and the models do not match. In fact, the models are vastly overestimating the impact of this. And I'll show you a little bit why these models, what might be behind some of that when you look at the funding and the money going into this. But from this perspective, these models can't even accurately predict what's already happened. How can they possibly predict what's in the future? And why would governments take those future predictions and run policies? That's a question I'll leave with you. Okay, I talked about that graph on the right. Remember I showed you that its temperature is going up. Well, if you think about Jersey, we go from anywhere from 0 in the winter to 30 in the summer. You know, that's the natural range of temperature change we see. When you put that graph of temperature on that scale, you don't even see a change. And yet if you take that and change the scale and pick the timing right, you can scare people and then put some colors on it. That helps too. And it can make a big impact. But, you know, be careful on this sort of thing. Here's another example of how manipulation can occur through the media. On the left, you see two, these are German maps of German weather persons, ladies. And the difference in timing, one is 2017, one's 2022. The numbers are the same. Look at the colors. Look at the visual impact that the media is trying to tell us. Look at the Time magazines. There was a time we thought there was going to be another ice age. I think some of you are old enough to remember that. If you go out today, you may think it's coming again. Global warming, same effect. So there's things happening, you've got to stand back. And that's why as geologists, we're very fortunate because we do think about much longer time periods. And we try and get some perspective. And that's what caused me to dig into this because it just didn't make sense. So why is this happening? What's behind this? Well, no one knows for sure, but Dr. Stephen Koonin, in his book, went through this and dug into some of the reasons why this might be happening. What's pushing this thing? Well, the media. So the point is it's a self-reinforcing alignment of perspectives and interests are coming together. What's amazing is how much a big impact that's had on the world. You know, they've done a good job. Media, the age of internet, headlines, there's a fire, there's a storm, gets out there very quick. So they love disasters, they love extreme events. Politicians, do you remember Al Gore was running and he was trying to get votes way back then about that same graph I showed you, but he didn't point out that the temperature occurred before the CO2. He just said there's a relationship, which was true. So certainly politicians love to drum this stuff up. Scientific institutions, when you actually dig into it and you see the number of papers out there that are pro-climate change and pro-CO2, you need to understand there's extreme pressure on them. People are being kicked out or not allowed to publish or present if they do anything except follow the party line. And there's lots of examples of this. So they're being, you know, that's not right. Sorry about that. And so the pressure from scientific institutions and scientists. And of course, activists and NGOs love this. You know, it's a great thing to protest, but there are things that protest that we should be complaining about, but this isn't one of them. CO2 is our friend, it's not the enemy. And the public, of course, hearing all this stuff, no wonder people would respond differently. That's all you're hearing. So here's the money, some of the money. The numbers you could dig in are much higher than this. But here's an example of 4.7 billion per year in one study that's being and the funds that are doing it that are being gathered in and attracted to promote this position. Well, no wonder they're doing this. Look at the kind of money behind it. You know, but what's also kind of shocking is that Oxfam did a report and found that 41 billion, nearly 40% of the climate fund distributed by the bank over the past 7 years is unaccounted for. Well, that kind of raises a flag and it's certainly a concern to me. So there's a lot of money out there and not all of it going to where you think it's going. Imagine if all those funds, instead of trying to reduce CO2 and trying to control climate, which always changes, what if they had simply taken that money, recognized that climate changes, and put it to mitigating the negative impacts of climate rather than trying to prevent something that's going to happen? You know, I think money would be well spent then, I think, including a Jersey. So, in a summary, I don't believe we're facing a climate crisis, and I don't believe it's being driven by CO2. Extreme weather events show no long-term trends attributed to human emissions of CO2. You're going to read otherwise, and I'd say, great, bring them on. Let's bring the data. Let's bring both sides of the story together and the people, and let's have the discussion. Some of the people I'm referring to here, I can bring in. William Happer, for example, I'm in contact with, and I think we can get these people to represent what I believe is closer to reality. Hurricanes, tornadoes, heat waves, droughts, forest fires. Not increasing. Do your own research. Look back, but don't look over a short-term time period. Look over a longer time period, because then you get a better perspective. Polar bear population. There was a fear that, they're all dying out. Well, they're not. In fact, there's a problem with too many of them now up there. And coral reefs. No, they're not dying. They're expanding. Look at the maps. See what's happening. The Great Barrier Reef, they have these reports. Oh, all this bleaching is happening. But if you look back over time, it's expanding, it's growing. That's a natural effect. So the rate of sea level rise, although it is increasing, it's small because we're at the tail end of it, and it's been stable over the last 6,000 years. So we're not going to make a big difference with our CO2 emissions, and we haven't. And then I talked to you about the models, and they're faulty models, so don't rely on those as well. So that's why, and I lived in New York, in Manhattan, a while ago. Here's a picture, 1898, of the Statue of Liberty, and 2017. It kind of looks the same when you look at the water. Well, the tide's only 3 feet. So it's not going to be the tide. So what you're seeing here is a reflection of what is really happening. Different parts of the world, depending on the basins and what is going up or down, you'll get a little bit difference. But overall, it's not a big deal, the amount of sea level rise we've had. It's very small and manageable. Now, you hear the word, the science is settled. Yeah, but wait a minute, 98 or 97, I don't know what number they're going with. Scientists say that this is true. Well, what are they actually agreeing to? You have to actually look at the question to start with. And so scientists do agree that the temperatures are increasing. They have been since the last ice age. They do agree that CO2 is a greenhouse gas, and as a greenhouse gas, it has to have an impact. But they do not agree the degree to which mankind's CO2 emissions are impacting temperature, or that this is causing a climate crisis. Many of them don't agree with that. Many of them do, but you can also, I've talked about the funding sources, and you have to question it, which says, let's bring them all together and have the debate. Here's a whole list of the scientists that I've used to research my work, and there's others in my report. And I'll give you a handout, and you can look at my full, complete research on this, and some of the facts that are there. There's a handout when you leave if you're interested. You can pursue that further. And there was 1,828 scientists. Ted likes to quote that in his articles to the paper. The number's growing, Ted. You'll have to update it. Saying there is no climate emergency. Natural as well as man-made factors are causing warming. We all admit that the CO2 has gone up in part because mankind has emitted it, but it's at the saturation point or close to it. It's having very little impact. And as a total basis, it was never that big an impact. Warming is far slower than predicted, and I showed you some of the graphs on that. Climate policies rely on inadequate models. They haven't been able to crack that nut. It's very complicated, changes in climate. CO2 is the plant life and the basis of all life on Earth. And it's important, and I've shown you that with higher CO2, our plant life responds very positively. So we're feeding the world by adding more CO2. We're not killing them off. Global warming has not increased natural disasters. And the sixth point they have, climate policy must respect scientific and economic realities. So let's respect that and have that. If you disagree, I'm all open for it. I think we need to hear different ideas. And in some of the write-ups I've put into the paper, I've asked for a debate. Deputy Jonathan Renoff said, no, the science is closed. Don't have a debate. I'm not going to have a debate. 3 years ago, I approached him when I was with PAC initially, and the chairman said, why don't you talk to him? This is interesting. I went to talk to him. He wouldn't even talk to me. He said, no, I know the answers. This is closed. So then I looked at his reports and what he was involved in with David Attenborough. Every one of the predictions in the reports he did are false, have been proven false over time. And yet I can't even have a discussion. So I'm not too happy about that. Okay, temperatures over the last 10,000 years were actually higher than today when you look back in the Minoan and the different time periods of mankind. We've done well up to 2 degrees higher. So this scare of 1 degree, that's nothing. Bring it on. The Canadians are cheering for it. Trust me. More deaths from cold, not from warm. The Earth has experienced over 10 times the CO2 level we're seeing now. 10 times the level. And when you go back and look at it, life has prospered. That's when marine life developed and started. Then the dinosaurs, they moved on shore. And when they all went on shore and life started developing there, we saw CO2 go down because plants took off and they're absorbing a lot of the CO2. The earth is greener with higher CO2. We've talked about expanded vegetation and forestry, crops, yield, etc. Many of the things you look at, and I'd encourage you to look at the other claims. Whenever you hear a claim something's going, dig in a little deeper. And I think you'll find over time that's not necessarily the case. Hurricanes, tornadoes, etc. And the models don't work. So why is this important? It's theoretically interesting. I'm a geologist. I love it. But let's look back what's happening here in Jersey. Let's get real a little bit. I'm saying that the claim that mankind's emissions of CO2 is causing a climate crisis, in my mind, is in serious doubt, and I invite you to consider this, at least as a possibility. Basic science, historic records, including those in Jersey, including when you look at go out to the beaches and find the tree stumps on the beach and things like that, they don't support that. Then let's look at our carbon neutral policy that came in and you've been asked to accept. This was never approved by the people. Any policy, according to the guidelines, need to be properly costed and the full implications laid out before it's approved. That was never done, and I've been a member of PAC. I'm now stepping down because now I want to start challenging the politicians, and I can't do that as a member of the Public Accounts Committee, as my colleague here knows. But to me, I can make a bigger impact if I could take the 22 million that they've got allocated for the next 3 years towards going carbon neutral. Just think what we could do in health, the wait lists, or in our roads, or in there's areas that really impact us. And trying to make a difference of our 0.001% to 0.001 by spending this money to go carbon neutral makes no sense, and it doesn't follow proper guidelines. And when I start making statements like that, that's why I had to step down from PAC. But I think this makes a bigger impact, and I hate to tell you that, share that with you, but I think this might make a bigger impact. So I talked about the funds to carbon neutral. And what about children? They're being taught this in your schools. There was just a big session about going out to the schools and educating them on the fear mongering and the world is we're doom and gloom. That's not fair. That's not right. We shouldn't be scaring our children. We should at least allow them to hear both sides of the argument. That's what the proper education's about. But that's not what's happening. So as I mentioned earlier, I do recognize there are alternative views and perspectives. That's the nature of proper dialogue and discussions. Bring them on. So that's why I'm calling for this debate. And I've got a handout there. There's a website for you. In the handouts, you'll see the websites. You can dig in as much detail as you want and see all of the research, the papers, etc. are well documented in there. And before I open the bar, you'll probably need that. I will open it for any questions or comments from anyone in the audience. Anything? Go ahead.
Just a quick question. With such opposite views on this subject, there are many talks going around at the moment would absolutely counter what you've just said. How do we bring the two poles to a central point where we can honestly and sensibly get to a consensus? Because it just seems everything is extreme, and from the normal perspective, is there if you look at the Royal Society, NASA, they have a view, you have a view. How do we get to that consensus point where everybody can sleep a little bit better at night? Because at the moment, this is part scaremongering. And it's just trying to get a point of reality in the middle. And how do you do that, Graeme?
Well, I hope by having dialogue. That's why I'd like to get a debate. I'd like for all of you to hear the other side and form your own minds and look at the records. And it's by having dialogue and not fear-mongering, not calling names. I've been called a climate denier, and yet my entire career I've chased climate, So it's by opening it up. I'm very open to hearing the alternative views. And when there's differences in data and stuff, let's look at the data, have the dialogue, have an open discussion, and stop trying to scare people. So I'm hoping, my answer would be, let's start talking about it.
And in your view, are there any governing bodies that can sit in that central position to bring all groups together?
Well, Well, America's moving in one direction. there are countries, but I'll come back to that. Sorry, go ahead.
I was wondering the same thing. The IPCC produces its report every 3 years
Yes.
by scientists from
Yes.
all over the world who collected data over the 3-year periods. And I mean, Stephen Conan refers to this report and says he actually reads it. But the report from the scientists don't appear in the media very much, because he feels that what you read in the media and what this report says, it differs. So why don't we see more in the media from those scientists who contribute to the report or discuss it, and who discuss the report?
I wish I had the answer to that. I don't know, other than there's a lot of money behind this. I can't come up with a better idea, but I will comment about the IPCC. First of all, there's a lot of scientists that were in there that have left now because they're concerned with they do the initial report, and then when it gets published and the headlines don't match what's in the report. So it even goes as far as that. So there's a lot of, all of these things, we need to roll up our sleeves and dig in and look at it. But I think it's important that in a free market, freedom of speech, etc., we get both sides of the argument out. And in little Jersey, I'm trying to do that by having a public debate, and I'd invite all these people to come in and let's talk about it and get the data. But the only thing I can think, it's not an answer unless you can ask each of them, but there's a lot of pressure. There's an awful lot of pressure and a lot of money behind this.
So they don't want to appear on CNN or whatever.
Well, they'll be,
with their views.
they want to appear, they're not allowed to appear.
Or they don't dare to.
No, I dare to. I'm going to see if people will allow me to do it. I'd love to get in this sort of stuff and talk about it. So many of these people do want to. Judith Christie was involved in that. Read her book. Some of these people I've talked about, they were in IPCC and had to leave because they're so frustrated with the real science of what they thought at least was the real science and what was being published. There's huge pressure on this. Go ahead, Ted.
Graeme, can I just point out to everybody, I've been trying to do it for some time, that the IPCC, the United Nations body, has already been told by 1,900 scientists that their method of modelling is totally false. And they've proved that it's false, and they've written 4 letters to the secretary pointing it out. And one of the signatures to that was the person who designed computer modelling for meteorology. And he said, you've got it all wrong. And 2 of the things they found was there were 4,000 weather stations that were being used to measure temperatures around the world, and nearly 1,000 of them did not exist. They were non-existent. And it was that kind of falsity that these scientists have uncovered, and yet they do not want to admit it to anybody.
There's a lot of pressure on there. A lot of this stuff we can't, unless you really dig in, we're speculating. But I've tried to share I referred to those same models and showed you the data. And the scientists that have been involved with IPCC, and some of them that were working with them. So there's, it's not all good out there. Go ahead, yeah?
Hi, thanks very much for your talk. It was interesting. I've got 2 questions. You've covered CO2 and the impact of CO2, or your view of the impact of CO2 on the climate. You haven't covered any of the other gases that are reported to result.
Well, they talk about methane is one that comes up. So, but what you need to do, first of all, with the rest of them, is look at the actual percent. CO2 is you go to water vapor is the biggest, then CO2, then when you get into methane, now you're down to, instead of 5, less than 1 or 0.5%. A lot of those other ones in isolation have an impact, same or greater impact, but when you look at the volume, it makes no impact. So that's where I would go, is look at how much of that, what is the greenhouse gas made of, and you start with 90% water vapor, and then start digging into it and see, and then you can look at the research, do the test and say, how much would you need to actually make an impact? Given, yes, it is a greenhouse gas, yes, it can have effect, but the amount present is minuscule. Sorry, you had another question.
Yeah, the second one was, as a geologist, I accept that climates have changed naturally over the millennium. My understanding of the issue we have at the moment with the climate is the rapidity of the rapidness of the change and how mankind can deal with that in the short term, not so much the long term, it's the short term over the next kind of 50, 100 years, 200 years, and the projections where we are headed now and how we can manage that, and then not as a geological perspective, because purely geologically the world will survive, plants will survive, humanity will probably survive, almost certainly will survive. It's just how do the more vulnerable in our societies manage over the next couple hundred years.
Okay, so first of all, let's say check your data. Here's the data over time, and I can go back to other data that I question that premise to start with, that we're now on runaway temperatures and they're taking off. So when you actually look at the data, that doesn't support that claim. Secondly, if it is heating and there's an issue, why wouldn't we take the money, instead of trying to think we can impact climate change, take it and do the things we can do, because it's warming, period. It is warming. And if that's impacting people, why won't we take that money and help them, put it into mitigating the effect? Don't argue about the cause, because we're not going to change it. Instead, take the effort and put it into helping. So I would say what we should do, if those people that are impacted, first of all, I don't think we're going to have the runaway. We certainly haven't seen it in the past, and the data doesn't support it. I would go back, and Ted commented about some of the data. I would look at all of that data very carefully, and then let's have the people that are looked at, both sides, bring it in and let's have that debate, because I think you'll find that that can be challenged. But even if we, and I acknowledge that it's warming up and has since the last ice age, so when we have records, well, no wonder you have a record when you're coming from the very low. Gradually, you cherry pick and you're going to find, areas where it's higher. But I would say take the money and let's find where the problem is and deal with the problem that way, constructively and positively. That would be my approach. Yes?
Could I just comment on some broader issues that you brought up, including things like computer modelling? How can you produce computer models that predict issues if you don't really interpret and present the data? And you've presented data which is very, very difficult to interpret within a computer model. Heaven help us if AI get onto this, because what are they going to do? As you can see, I have some skepticism about this. But I just wanted to relate to a very similar line of study, which is that being done by how information is presented, particularly in terms of energy. And the name Jean-Baptiste Frisot comes to mind.
Mm-hmm.
I don't know, have you?
I haven't read him personally, but I see Ted nodding his head. But by the way, please send me, because you've got my contact.
Called More and More and More. It's just been published. It's brilliant. It echoes a lot of what you're saying. And it talks about two main things from my reading of it. First of all, you need to have the data and the influential data properly displayed, not be selective. And he does this with essentially energy consumption. And basically he is questioning things like transitions, and I'm digressing.
That's okay. No.
And it's absolutely brilliant, because he really points out that now we're producing more coal than we've ever produced because of China, etc., etc. And that all the energy models that people have wanted to produce as matters of concern are actually incorrect. And I would encourage anybody to read that book. It is.
So please send it to me. You pick up one of my papers,
sure.
and send me an email, because I'd like to do that.
But it's an example of what they've done with energy. And the last point I want to make is that when you looked at, say, United Nations bodies, when you looked at the American government, they put the people into those positions that they wanted for their particular view. So there's so much personal and, let's say, professional bias even.
On both sides of the story. I mean, let's not kid ourselves. It could. So the most important thing, I think, first of all, is the data should always be available and up, so anybody can take it, look at the source, challenge the data, and look at it.
Yeah.
That's absolutely, it's like a fundamental premise. And that isn't always happening.
No.
And so that would raise a flag immediately. Show me the data, let's evaluate it, see how valid it is. So I think you raised some good points. I'm for complete openness and dialogue.
The power of the data is fundamental.
Oh, absolutely. And where did it come from? And what? There's no point taking data in the middle of cities and then saying, look, it's gone up. You've got, because you've got a heating effect, a heating island effect of the concrete. So you've got to be careful where the data's coming from as well. But good points. Thank you for that. I'm interested in energy, obviously. We talk about coal, and the Chinese are born in coal. If you take the CO2 out of the equation, there's a lot we can do to burn coal and get rid of any of the pollutants other than CO2. So we could actually tap in, the UK could tap into this great resource. And same with hydrocarbons. We've already cleaned up the engines a lot. We're not smoking like we used to and steaming out stuff. But if we put all our energy into say, okay, let's go after the real problem. Let's clean up. We all want a cleaner environment and cleaner burning. And by the way, we're going to need not just oil and gas. We're going to need nuclear. We're going to need energy is a huge need of society. The reason we got out of the doldrums in the 1800s when things took off was because we had cheap energy supply. That made a huge transition. Africa, other countries are begging for cheap energy supply so they can reach the same standard of living as us. What right have we to say, no, you can't because you're going to kill the world? We'll take our share of it, but no, you can't have it. It's just morally to me is not right. A good point. So I would like to get that book. Thank you. Any other comments? Yes.
I'm really interested in the effect of the growing population of the world. I mean, any increase in droughts, for instance, in Africa, is bound to have the effect of people dying. But it's really the sustainability of the size of population that the world has currently got, given that its growth over, say, even 1,000 years, and how you inject that into the fact that an awful lot of people are going to die, given that there's going to be droughts.
Regardless of the cause. Well, there's a couple observations. A person I've listened to and read, Jordan Peterson in Canada, he talks about this issue. First of all, look at where are the growths in populations occurring. They're not occurring in the wealthy and the well-to-do. They're occurring in the poor. So if we can raise the standard of living of these people by providing them cheap energy and reliable energy, I think the net effect of that will be more of a flattening of population. The second point he makes is, no, we're not, this isn't doom and gloom and we're not going to run out. Yes, there will be more deaths in numbers because there's more people, but we're not at that tipping point where the world is overrun and we're going to have a big problem. So if we can bring up the standard of living, they're going to have less kids. That's just, we've already seen that. In North America and in the developed societies, they're not, the only reason the population is going up is because we're importing people, not because we're having more kids. In spite of I'm trying to lob me my wife, but she says no. It's easy to. No, but that's a fact. So I think we can get if we can get the standard of living up, that'll help with that effect, and it's not as big a problem as you're being told. I don't think.
You talk about clean energy. What do you think Jersey should be doing in that thing, and do you have any views on these wind turbines?
I do in fact. In fact, what I'm trying to do is get an energy conference where we get each of the energy sources, the people behind it, and we've got one of them right here, Simon. They come in and let's have a conference, a 2-day conference where each energy source can come in, make their pitch, and share with the citizens of Jersey and the state's members, why should you pick my energy source as the best source for the future? And I don't think clean, I've tried to share with you this whole clean thing, throw the CO2 thing out of it and look at, because you can burn oil and coal and gas clean if you get over the CO2 thing. But I don't think that'll be the answer. I have my own views. I think the one that would win would probably be modular nuclear reactors. Nice small one, just right next to wherever we have our oil. It's very safe. That's why they need to sell and share with us of that. But I wouldn't, that's not how I'd approach it. I'd say let's look at all of the sources, realistic sources, tide, solar, wind, oil and gas, and look at that. And let's look at, why don't we just renew our contract with France? Let's look at all of these things, make a common calm, rational approach. Look at it, not just the politicians, but let the public see this. And so that's what I'm pushing for, is to have that kind of conference. But what would I be looking for is tell me your 50-year or 100-year cost outlook. What's it really going to cost us? Forget about subsidies, everything else. And then look at also, you got to, if your windmills are breaking every 10 years, put that into the equation. Personally, the two least effective from an energy density perspective, the least effective are solar and wind. And wind, you've got the added problem of the wind. What do you do with all these turbines? What do you know, the whales certainly don't like it. There's other issues of birds, but even cleaning that stuff up. But let's give them their day in court too. But let's do it not in an isolated, this is the answer, but let's compare it across all of the different options, realistic options, and then let's see, and let the people make an informed decision. That's what I'd like to see, and we're pushing for that. So we're going to, two things we're pushing for. One is that energy conference, and the other, I'd like to get a proper debate so that I'm not the only one talking. In fact, I'd bring in William Happer in, somebody a lot smarter than me, and let's hear the other side. And let's have that debate so you don't get just one side, but you open it up and have an honest, open discussion. So that's what I'm pushing for. Yes?
Graeme, it strikes me that hydrocarbon resources are finite. They are getting smaller and smaller as time goes on.
Correct.
Okay, some countries have still got plenty of oil and gas, but the fact of having to start exploiting shale gas says to me that they're starting to run out of gas supplies if they're having to try that hard. As time goes on, it's getting more and more expensive to use hydrocarbons as well. Would it not be sensible not to have all our eggs in one basket and to actually transfer as much away from hydrocarbons as possible? Because they have a value in their own. For plastics, all sorts of other things you can't make without them.
I completely agree with you. And that's why I would promote multiple energy sources. But I also wouldn't let it be government that dictates that to us. I would say let the free market system, I'm a firm believer of the free market system, supply and demand. These things will sort themselves out. The reason we're finding more oil and gas in farther away places and more difficult is the price went up. And it went up because supply went down. So supply and demand and change, but for sure it won't last forever. But also, I think it'll change way before that just because new technologies, whether it's nuclear modular reactors or other, I'm all for that. I think we need to explore all of those. But also, we need to do it and let free enterprise do it. Don't let some politician with his pet project come in and ram it down our throats. I don't think that's the right way to do it, personally.
The free market is we'd still be smoking like chimneys if that was the case, because there's vested interest in maintaining the supply of these things.
I'd challenge that. I would.
No,
but I would say if there's a buck to be made, somebody else sitting across will also come up with an idea. You know, it's not as.
Trying to suppress other alternatives deliberately.
No, I disagree with that.
Well,
I disagree. I think there's been a lot of oil companies, and I'm in one of them. We're looking at things, not because we're trying to save the world or we're running out of oil and gas, just because we're opportunists. And if we can find a way to make more money and do something, why wouldn't we? That's what our shareholders want us to do. We're in the energy business. Let's find a way. So I think you're hearing things about this control, but I do agree it's a finite resource. And let it play itself out. We don't have to panic. I'm all for it, and I think the answer for Jersey won't be bringing in more oil and gas, although having that oil backup is great in case something happens, you know, to switch it over. But I think time will tell. And coal in the UK could be, once again become, instead of shipping it all off to China, we may use it ourselves. But we'll see. I'm a big believer in free enterprise. I think people are smart enough, and give them a chance, it'll play itself out. Any other questions? You're just not to throw you off, but there's a bar open there, you know. Is that enough? Okay, thank you very much. Thank you for your time. I really appreciate